take it away with your questions.
Well, I have a burning question, and I'm glad to see all of us PhDs are on here because this applies to all of us. And Bonnie, you probably know what my question is. I cannot, for the life of me, figure out how to use these darn tables, the chi-square and the chi-square and the z-table. And so I wondered if you could take a minute to just, based on the sample problem, how you plugged these numbers in, because I just can't figure it out.
Oh, thank you.
I've done these tables in the past in other stats classes, and I even YouTubed it last night, and I just was left more confused.
Thank you so much for voicing that question, because for the life of me, I cannot get from step 1B to step 2.
Me
and
either.
Yet I understand the concept, and I can go to the file drawer, and since my spreadsheet is done, I'm like, okay, I get this, but I just don't. Yeah, I even was texting my 19-year-old to say, help me with the stats.
So yeah, I wonder if, I think it could be helpful at some point for the course to have like a PowerPoint walking us through these tables. Because I really like stats for dummies. Even though I've taken inferential statistics at the graduate level, these tables are throwing me for a loop.
For me, they just don't stick. I learn it and then it's gone, and then I relearn it. And
okay, are you seeing the how-to sheet?
Yes, I can see that.
Okay. So this part all makes sense. I'm going to close this just because.
Yeah, I'll answer for myself. I did all the calculations on this, and I understand where to click and how they auto-populate the answers. Okay. I understand that, but when we get down to step 2, that's pink, and it says, look up this chi-square with 3 degrees of freedom in the table.
What table? I didn't know what table.
So there are standardized tables for all of these statistics in both of your textbooks. So if you look at, let me just grab, so I've got Courtney and Watkins out.
Okay.
And chi-square critical values table is A5 in Courtney and Watkins.
Okay. Well, listen, Amy, are you there too? Do you have that open?
Yes.
Okay.
Appendix A?
A5.
Oh, A5.
It's page 810.
Oh.
Page 810 in Courtney.
Oh. I guess it would help if I had the right book. Oh my goodness.
There's the other one too, but they're formatted differently.
Okay, all right.
And this is as far as I got. I found the table in Courtney and Watkins, and I also found one in Monroe, but I think it's easier to stick with one book. But now I'm lost. So given that number 0.000091, where do we plug that in on this table?
So go to your degrees of freedom. For this example, it's 3.
Yep.
You have 4 studies. It's the n number of studies minus 1 is your degrees of freedom. So it's a 3. So if you're on page 810, can you guys hear me okay?
Yeah.
Okay. Go to page 810. Your degrees of freedom are on the far left-hand side. And
okay.
If you are, your alpha is at 0.05, which is what we usually set it at, you just go down and your critical of chi-square is 7.82. And your 0.00097 is clearly less than that.
Okay, yeah, it's way to the left of that. Okay. So does it say somewhere that we should look in the column that says 0.05?
Um,
Like, does it say that that was the alpha set a priori for these studies? Or, I
That's
mean, how do we know to look in that column?
just your typical, unless you're told differently, it
Okay.
usually assume that.
Okay, that wasn't clear either, so thank you. That was the other thing, is I found the degree of freedom as 3, but then I had no idea what other column to look at. And I mean, so this is helpful. So we're gonna, the default is 0.05, and 7.82 is way bigger than 0.0009. So that's how we make that call.
Right. Now,
Okay.
the thing I'll say about that is remember how to interpret this test of heterogeneity, because it's different than how we interpret everything else. Are you seeing the how-to sheet again?
Yeah.
Okay. So in this pink area, it really gives you the hint. In this case, P is greater than 0.05, and that's good because it means there's not inconsistency in the Z's.
So Bonnie, can you explain how is P greater than 0.05 in this case?
Because you're looking at your critical values.
Yeah, but so I guess I understand that 0.009 is way to the left of this value. But I still don't understand how that's greater than 0.05. Do you guys?
So the critical value in the table of 7.82 is a much bigger number than your 0.0097.
Right.
Which means that the Z's are closely related, right?
Yes.
Okay, wait a minute. I gotta write this down.
In my case, I was just not trusting the numbers because they were so far away from the critical value that I thought I was looking in the wrong place.
Well, me too. That was part of it. I was like, this can't be right. So Melissa, thank you. So let me just repeat that. So because our number is 7.82, and 7.82 is way bigger than 0.0009, I still, so then we conclude that that means P is greater than 0.05.
Yeah.
Wow. Okay.
And maybe, let me just find in the other book to see if it's, we were to use in the other chart. Because each book sets them up a little differently.
So if our number, let's say our number was 7.82, then what would our conclusion be? That P equals 0.05?
Yes.
Okay. And if it was, what if our number was
9.
yeah, 9 at the level of 0.05?
Then P would be great. No, less than, right?
Yes.
And our Z's for the studies would be all over the place. And so it would not be, so more research would likely be needed. Yes?
So if you're in that 3 degrees of freedom and you look over to your right and you see the 9.35, that corresponds to a 0.02. So that means it's less than 0.05, right?
Oh, yeah.
Does that help you understand it a little bit better?
Yes, yes, yes.
It means that it's less than 0.05?
Yeah, because you're at 0.02.
Oh, right. But we would only look in the 0.02 column if instructed to do so. Like, we're going to always default to 0.05 unless we find out that the study says otherwise.
0.05 is your cut point, right, of significance.
Right.
You're trying to match your degrees of freedom with the value you get, the critical value you get. And I think what throws you is your critical value is so small that you don't realize that means it's less than 0.05. But if we gave you a 9, it would go, I'm sorry, I said that wrong. Greater than 0.05. But if it was 9, then you'd be going to your right in the chart, and you'd see that then your alpha actually becomes a 0.02. That makes sense?
And then it would be less than 0.05.
Yeah. And then
Yeah, okay.
Okay.
with your
I think so. Gosh, in all the scenarios I did in other statistics classes, I never had a number that was this much of an outlier. And so that's part of why conceptually this is really hard for me to get, because I'm used to seeing numbers fall on the chart.
yeah, and it'd be nice if the chart was more complete so
Yeah.
that you could see that, but it's limited to what's the critical value. Is it
Got it.
is it less than or greater than 0.05?
Okay, I think I understand it.
Gotcha.
Do you, Amy and Melissa, do you guys understand it now too?
Yep.
Okay. So now to the Z table. And which number did you plug in and where and how?
All right, which assignment are we talking about?
Same one, we're still on the same. So now we're going to step 3
Okay,
of this practice assignment. So the green highlight, it says now use the Z-test formula to find a test Z,
yeah,
and then use
I
the
see.
Z-table to give, yeah. So what is your test Z?
it's at 6.092 that you get after you do the statistics to come up with your Z value.
But how did you do that? What did you do?
Plugged into right here. Can you see that?
No, oh, up there.
Oh, wait, it's the test Z stat, and in the green, highlighted in green, the 6.0924.
That's the value.
Oh, my sheet says 6.12. Okay. So do you have to do a separate calculation to get that number at this stage?
The Excel sheet has all the formulas in it.
Right, but so that already populated before we even did step 2, right?
It populates as soon as you put these numbers in.
Okay, so you just have a different number than my practice. My practice sheet has 6.12, and your practice sheet has 6.09.
Yeah, there's probably something different in these numbers here or something. But
Yeah, okay.
when you plug this stuff in,
Mm-hmm.
it calculates for you.
That's what I thought. Okay. So at this point, there's no extra steps. We just look in that box and we see that it's 6.09. And so then I'm open to the Z table on page 802 in Portney.
Yep.
And so where do we plug in 6.09?
So your table goes up to 4, right?
It does.
So you're above that. So what can you say about, what can you say about that then?
Well, so it's not under a normal curve. Because this table is only for areas under the normal curve, right?
Yep.
So that means it's not even under the curve. It's, so I don't know, what would we say? That it's greater than, I don't know. I'm stuck, I don't know.
So your, remember that your area, that's under the curve is that area between 0 and Z, right?
Yeah.
So the number you got is greater than that, right?
Yes, it's above the Z,
So
right? Is it the area above Z?
it's, no, because that means, let's see if the other book, they set the tables up a little differently in the other book, and I'm just wondering if that's a little easier for you to get. I'm just checking real quick.
Okay, the other book, it's on page 515. In the other book, it goes up to 5.
And this one's set with your p-values at the top.
Yeah.
So does that make it easier for you?
Yeah, I like this one better, actually. Personally, I like this one, the one in Monroe better. Okay, so looking in Monroe, it's greater than 5, which is a p-value of 0. So we say that it's less than 0.05, which means, well, which is consistent with what you put on the practice example. You said P is less than 0.05. But what is Z is greater than 1.96? What does that mean?
Well, that's back to your normal curve. And if you're looking at the curve, so remember your normal distribution curve, it's the teeny little tails on the ends.
Yes, okay.
1.96 on both sides, you know?
Yes, okay, I'm drawing it for myself right now. Okay, yes.
So that's what it's talking about.
And so in this case, because it's a 6 something and the chart only goes up to 5, and that falls under a p-value of 0, then that means that Z is greater.
All you need to really do is that the P is less than 0.05, which you can then use to answer your question, right?
Well, because it's 0, that means it's less, 0 is less than 0.05.
Right.
And that's what we're basing our answer on.
Right.
Okay. Okay. Okay.
So you're asking two different questions with this heterogeneity question in the pink and the Z-test question in the green. So, and you interpret those p-values differently, so don't get confused.
Okay, so when we're, and I don't want to hog this whole conversation. Amy or Melissa, did you have questions before I ask my next question?
No, these were my questions too.
You're doing great.
Okay.
You go, Ann.
Okay.
If you have questions about that after, but it makes good sense to finish this one, doesn't it? So
Yeah, no, this is great. I mean, really, this is so helpful because I really did not understand any of this when I got to this point.
yeah, so for the heterogeneity in this example, your P is greater than 0.5, and that means that these studies are not heterogeneous, they're homogeneous. So what does that mean? That the studies are consistent, that not one of them's finding that the intervention works and the next one's saying it doesn't.
That's a good thing.
So that's a good thing.
That's a good, okay, that's good. Okay.
Then you get to the step 3 and you use the z-test. And what's that doing? That's combining the findings of all the studies and coming up with, does this intervention work? Are there differences between these two groups when I combine all 4 studies? And your P is less than 0.05. So how are you going to interpret that?
The intervention works.
Exactly. So when you pool the findings of all those studies and all those different sample sizes, and you come up with the weight of each study based on the sample size and their findings, you come up with this overall difference between groups when you pool the studies. Does that make sense?
Yeah. So if the studies were let's say P for step 2, let's say P was less than 0.05. That would make it studies heterogeneic, which is not a good thing.
It would.
And then further, if we also found in the next step that P was greater than 0.05, then that means the interventions are not necessarily working when they're combined. So we would conclude that we can't base, we're not going to base any new clinical decisions based on these numbers.
And you might get a mix of those two. So
that was going to be my next question.
You might mix and find out that they are heterogeneous findings. So not every study finds the same thing, but when you pool them, there's a significant difference. So then if you go over here to like the studies in, if this little sample of 30 is the one that finds the intervention doesn't work, but all the rest of these big samples show it works, then you could possibly still get a significant difference with your z-test. So there's all kinds of different mixes.
Okay. Okay, I think it's all falling into place.
That makes sense to me. Finally.
And then the last thing is your file drawer.
Oh, yeah.
And your sheet should calculate it for you, and it should be that number. And that's the number of studies needed.
I can't read that. What does it say?
This example says 50.
50? So that means we got a good sample of studies, because it would take another 50 studies to potentially discredit what we found.
Right. What would it mean if I had a 2?
Then we would have tenuous results. That it would mean that only 2 more studies could throw everything off.
Yeah, if there were 2 studies out there that weren't published in somebody's file drawer, and they didn't get it published because they didn't have significant findings, so they just tucked it away, it could invalidate what you found. So you have to, especially when you do this meta-analysis, you have to interpret with caution, because you know there are some unpublished studies out there. You just know it.
Yeah. Well, and did this number in the orange box, did that self-populate too? Was there an additional?
Yeah, it should.
Okay.
It does, but this is what, and from last week, I remember that this was happening to several people.
Yeah,
On my practice sheet, it populates to 1,
Yeah.
which
Me
I
too.
think is where the error in the formula is possibly, but we just need to interpret it at 1
right,
and state that only 1 study would invalidate our finding,
correct.
which would mean that we would want to not probably change our practice according to these results, even though they're looking like they have potential or something like
Yeah.
that.
That would be perfect. And as we talked about last week, Melissa, there's several people who were doing the calculations by hand and think there's a problem with the formula. And I do not expect you to go into that much detail. What I'd like you to do is use what's calculated, because it's not your fault if there's an error in the calculation.
Yeah, that's good to know.
Okay.
Just use what comes up, and then you're going to submit your Excel sheet with the calculations and then your answer to the questions.
And Bonnie, that brings up another question. So I think if we have to do if we have 2 different Ds, for example, and so we have to zero out the first D in order to calculate the second D at the top. Do you want us to, I don't have to show you those calculations, right? Just
plug it in.
Yeah, you're going to assume that you're going to know how I got the number.
Right.
And do we just take a screenshot then of this Excel sheet and embed it in our document?
If you want to do it that way, or you can submit both sheets.
Okay, perfect.
As long as I get the pieces I need to grade it, I don't care what it looks like.
Okay. Okay.
Other questions about the meta-analysis? Julia, you got anything?
I do. So I'm not quite sure I understand the 2 Ds. Would there theoretically be 2 different worksheets if you use the different Ds?
You can, the worksheet only has 1 spot to put a D in. So you calculate what you need and you plug it in, and then you calculate the other one and you plug it in.
So you do it twice. The first time you use the 0.89 and then and plug that in, and then the second round you use the 0.5.
Yeah.
Am I getting?
Yeah.
Okay. So you're really doing this twice.
And then you plug the what you need down here is your Z-scores, right?
Yeah.
Yes.
So we're still talking about the practice problem, right?
Yeah. Uh-huh.
Yeah. So what I did, Julie, is I did the 0.89 and then moved those numbers down to study 1 in the blue box. Then I zeroed out D again for the 3rd study and put those numbers in again, and then moved them down to where the 3rd study goes.
Yep, that's exactly correct. And then you have to make sure the ends are correct. And then the rest should be calculated for you.
Oh, and Bonnie, there was one more point I wanted to make. So you know how it instructs us to get the average Z-bar,
Mm-hmm.
and we add these 4 weighted Z's up and then divide by 4, and we get 27 something. And then in your example, you converted that to 0.27. But then we don't do anything with that number.
Yeah, you can use these numbers that are here. You've got a Z-bar in your test statistic.
Yeah. But even still, we don't do anything with the Z-bar in this assignment.
Right, right.
Okay. Okay, I just wanted to make sure. Okay.
Okay, so now I'm gonna just really sound as stupid as I feel in asking this question. I have been trying to wrap my head around where these numbers are in Choi's article. This has nothing to do with Choi's article. This has everything to do with just this worksheet.
Right.
Oh, for God's sakes.
They're two separate. So sorry.
Okay.
So sorry. No.
No,
Well, her-
obviously I'm the only one that thought that, so I have been like
Well, no,
beside myself trying to find values that didn't exist.
Now, Julie, what I will say that you should be able to replicate what she did in the Choi article with the worksheet, with the formulas. But don't go there because it's too much work. But they're not connected.
well, and I can sound really stupid now too, Julie, because I don't even know, I didn't even factor the Choi article into any of this.
Just an example.
Like, what Choi article? What are you talking about?
Thank you for that. Your comprehension far exceeds mine. I'm like, there must be all these other calculations behind the scenes that I don't get to numbers that don't exist in this article. So
Oh,
now I feel like maybe I can actually tackle this. So thank you, Anne, for bringing this all together.
of course.
I'm
I have not been on video because the look of complete confusion on my face was not worth sharing.
I don't even know what I look like on video anymore at this point. I'm just relieved that I think I understand this finally.
It certainly makes much more sense now that I have it in the context of the worksheet and with
I'm
everything.
sorry that I tried to put the additional resources in to make it simpler, but I think I maybe made it more complicated. But maybe what I should put in the assignment is use the how-to worksheet. And then the empty template.
Well, and I think, Bonnie, like I said before, I think it would be helpful to somehow incorporate instructions on how to use the tables.
Yeah, it's a good suggestion.
Yeah. Because that's where I got hung up. It sounds like several of us got hung up on that. So,
Oh, Amy, you're still looking puzzled. Are you okay?
Actually, I'm great. I understand this. I just didn't, what's my first question is, what table? I didn't know what table. And so now I get it. It all makes sense to me. So yeah. So thank you to both.
And for me, even after I found the table, I was just doubting. I had such a low confidence in my understanding of what I was doing that I thought I must be looking in the wrong place if my critical value is that far away from what's on the table.
You're not close. Yeah, you're right.
yeah, me too, Melissa. That number really threw me. I thought, wow, what does this mean? Why is it so far off? But now I get it. That can happen. So, huh.
So
Are we ready to leave it meta-analysis?
For now, Bonnie, I might have more questions later, but I'll reach out if I do.
Okay.
For
Julie,
now, I'm okay.
were you going to ask something about this or something else?
No, I'm good for this. Now I need to do the actual real assignment. So once I get into the actual assignment, if I have more questions, I'll reach out.
Right. Julie?
So my question is, the 3 studies that we're looking at is plugging in data 3 different times. Is that correct?
Well, because they all have different inputs, you have to decide where up here they input. And what you need are the 3 z-scores to plug in down here.
Okay.
And read the assignment carefully because there's one little bit tricky thing about the assignment with being able to interpret and use this.
Well, you gave us a hint. Is that what you're talking about?
Yes.
Yeah. Yeah. which was very helpful. Thank you for that, because I would have
Yeah, I didn't want
total sense.
I'm trying to have you do the exercise, build your confidence that you can do this and interpret it without making you crazy, but I don't think I did a very good job. Okay, questions about other things? You guys probably noticed, but Anne sent a good question about a test question. So people got a quarter of a point on a question just because the possible answers, there were actually 2, but not 3. Anyway, if you missed the inferential stats question, you got credit. So any other, do you have questions about that next analysis assignment, or are we going to wait for another day for that?
Honestly, I personally haven't
gotten there
that far yet. So I don't,
Totally.
I have all I can handle right now.
yeah, I'm just not that far ahead.
No worries. Just thought maybe there were questions.
It's one day at a time in my world. One day at a time.
Really
Me too right now.
manage COVID on the side.
I do like these office hours, though. It's so good to see people, even if on Zoom.
Yeah,
It's good to connect and collaborate like this.
yeah.
I agree, Anne. Thank you. It is nice to see everyone.
Yeah.
And
Yeah.
I swear you learn as much from your cohorts as you do from the faculty. So the fact that you're strategizing and asking each other, and I love it. So it's good. It's good. We should probably build more in if we're going to live life this way.
I know. For an indefinite amount of time, we're going to live life this way, probably.
Sure looks that way, doesn't it?
Yeah. I went to a friend's wedding on Saturday, and it was just so nice to get dressed up and go to a church. And even though we were sitting miles apart from each other, it was still nice. Like, oh, I can't wait for the world to get back to that.
Did everyone have masks?
Yeah, we all had to wear masks for sure.
Yeah.
Yep. Oh, yeah.
Those
But the bride didn't. The bride and groom didn't have to.
will be some interesting pictures, won't it?
Well, once we went outside to take pictures, we all whipped our masks off and just took pictures without masks. But in the church, we were very good and compliant. So I will confess, we broke the rules a little bit after, but yeah.
All right, I'm going to quarantine from you.
Well, I wasn't getting that close to people.
Kidding.
I know. Yeah, Bonnie, I wish I had questions about the next assignment, but honestly, like I said before, I'm not that far ahead yet. So this is good. I'm going to focus on this one now and get this one done.
Yeah, relieve your anxiety, get this one done.
Yep.
And I quite honestly don't know if there are office hours next week or not, but
I don't think there's office hours again until, I wrote it down in my calendar.
I think not until the 10th is the
Yeah.
next one I have.
That's, yep, the next one is Tuesday, November 10th.
Mhm.
You're right.
But our next assignment after this is actually not analysis 2, it's our outline, correct?
that's right.
Oh,
Okay.
yeah.
We're working on that. People have just been emailing me questions about that. Analysis 2 isn't due until November 16th. So
Okay.
we're all good. And Anne knows this already because I've been haunting her for a while. But you guys just email me. Don't fret about stuff. She wanted to meet earlier today and I couldn't because I was booked. I've been on Zoom since 7:30,
Oh, geez.
but I'm happy to just connect if we can. 3 of us connected the other day because Christina emailed and somebody else emailed, and I said, let's just hop on Zoom. So don't fret. Just send me an email and we'll connect.
Thank you.
Yeah, thanks, Bonnie.
Yep. All right. Is there anything else?
Thank
No.
you,
I'm
everyone.
good. Thank you so much.
And thanks for asking all our questions.
Yeah.
Yes, that was very.
Actually, I'm delighted that we all had the exact same questions. It makes me feel better. So that was good.
They're delighted that you knew that you just fire them at her. She'll get it. All right.
Thanks, everyone.
Thank you.
Take care with the COVID stuff, and I'm here if you need me.
Okay.
Thank you.
Thanks,
Thank
Bonnie.
you.
Thanks, everybody.
See y'all.
Bye.